Hello friends, good morning. We are discussing about uh, stiffness factors. What is the stiffness? What is distribution factor? How they are calculated? How end moments are calculated on the basis of distribution factor? How questions are generally asked? Let us see. So dear friends, we were discussing this question. So in this question, he will ask these points. I told you whenever you want, you can convert a fixed support into hinge support. At this fixed support, three reactions are there. I want to see that. Look, this is hinge support, means it will generate two reaction. Now these two reaction will disappear as I have seen this hinge support, but I will see this moment. Here also I will write this hinge support and this moment. So whenever you want, you can convert a fixed support into hinge support by applying the end moment on that. So look here, in this case this was joint, rigid joint, right? This was rigid joint and this was member OA. Far end is fixed and this joint is rigid joint. I want to convert this rigid joint into hinge joint, so I can convert. This is O, this is A, provided that I will have to apply the moment at this, which I have already calculated. What is the value? OA, MOA. MOA is this 4 plus 4 means clock. So MOA is like this. So I can apply like this 4 kilonewton meter. Now he asks you calculate the slope, calculate the rotation of joint O. See friends, since this is the rigid joint, hence the rotation of each member at this joint will be same. For example, there were two members like this. This is the joint O, this is A, this is B. Whatever loading is applied, either rotation will be like this or rotation will be like this, like this. Means either rotation, net rotation will be anti-clock or net rotation will be clock, which can be, since it is the rigid joint, so all member will rotate similarly. So you can say that you can convert this is hinge support and this is hinge support. Due to applied loading, we can calculate the moment. For example, these are the moments. So now we can calculate either this rotation or this, and if this M is known, for example this is M, this is M by 2, this is also M by 2. Now we can say that this theta, since far end is fixed, this is simply solved, M moment is applied. The direct formula ML upon theta will be ML upon 4EI. This will be ML upon 4EI. So we can calculate like this. For example, this is the question. Now I want to calculate rotation of joint A. So whatever will be the rotation of joint A, means joint A will rotate clockwise, so all the member will rotate clockwise with the same angle, like this. So which can be calculated from either figure. For example, from this, so we can say that it will be like this. So this is the moment, or this will be theta O. Let us suppose this is theta O, and formula will be, since it is 2 meter, it is EI. So answer, and M equal to 4. So theta O will be ML upon 4 EI. M means 4, L means 2 upon 4 EI. So answer will be 2 upon EI. ML upon 4 EI means answer will be 2 upon EI. So this is the rotation of this joint. It can be calculated from either. For example, I want to calculate from this OB. Means I can write this OB as, this is hinge, this is hinge, B is hinge, and at O I can write hinge like this. This is B, this is O. Now MOB, apply the, since I have converted this from fixed, so apply the moment. So MOB is 2. So this is 2 and it is 3 meter, and this is EI. So like this. This is all again will be theta O, can be calculated from this figure since far end is hinge. So answer will be ML upon this will be ML upon 3 EI. M means 2, L means 3, ML upon 3 EI. So it will be again 2 upon EI. So you can calculate this rotation of joint O from either of the figures. Rotation of joint O from either of the figures, right? Now he asks you also find out theta B. This is the theta B. So you can say that from this figure, this deflection theta of this end will be ML upon 3 EI, and of this will be ML upon 6 EI. So theta will be M. M means 2, L means 3 upon 6 EI. So answer will be 1 upon EI. So the rotation of this joint will be 1 upon EI, and of this joint will be 2 upon EI. So similarly we can calculate these theta from either of the figure. For example, if we want to calculate using OE, we can also calculate from OE. Answers will be same. So dear friends, this is the concept of stiffness. Now how to solve questions and what type of questions are generally asked in the examination using stiffness method oblique moment distribution method. For example, let us take a question. See, this is the question. This is the beam. This is question. This is 40, 1 meter, 1 meter. This is 4 meter, and this loading is 12. This is EI, and it is also EI. It is EI and it is also EI. Now this is A, this is B, this is C. He asks you analyze using moment distribution method. Dear friends, had it been the one span question, so I have remembered the result. But if more than one spans are there, how will we calculate? We will assume this end, since it is not completely fixed, it is partially fixed, we will assume it as fixed. Now assuming this end B as fixed, and so we can write down beam like this. It will be 12, it is 4 meter, it is 40, it is 1 meter, it is 1 meter. Now we can calculate end moments. The direction of end moments will be like this. I have already told you the moment will be like this, because beam will had it been simply supported beam, so it would bend like this. It would bend like this, so the moment will generate like this in order to make this theta 0. So the direction of end moments will be like this. Now friends, we will calculate these end moment diagram. What is the value? This is the PL by 8. 40 into 2 divided by 8 means 16. This 40 into 2 divided by 8, this will be 5 into 10. This value will be 10. This value will also be 10. It will be WL square by 12. So this value will be 16. This value will be 16. Now I told you that we will write sign convention, means anti-clockwise negative and clockwise positive. So this is A, this is B, this is C, this is D. These are not the real end moments, these are the fictitious moments, or these are the wrong moments which we have to correct. Because why these are not the correct moment? Because let us suppose you write MAB. So MAB is 10, okay, sorry, minus 10, it is anti-clock. MAB is anti-clock. Now MBA is, since it is clock, take positive. Now MBA, this is B, this is C. MBC, it is anti-clock, minus 16, and MCB is plus 16, since it is clock. Now dear friends, since at joint B there was no external moment, hence the net internal moment should also be 0. So this answer MBA plus BC should be 0, but it is minus 10 plus 16 means minus 6, means this joint is unbalanced. So answer is incorrect, and so it should also be incorrect, because we have take an assumption that the ends are fixed, but in reality ends are not fixed. So we need to make the correction at this joint, because this joint is unbalanced. So how we take correction? First of all, we calculate stiffness factor, distribution factor. The procedure of calculation of distribution factor is like this. How many joint? Only one joint is unbalanced, this is B. So you will write this is B. Members are BA and BC. You will write K of BA. Since far end is fixed, so you will write 4 EI divided by L means 2. So it will be 2 EI. Since far end is fixed, K will be 4 EI divided by L is 4. So answer is EI. So now we will calculate summation K, total stiffness. So it will be 2 plus 1, 3 EI. It is 3 EI. Now distribution factor DF will be 2 upon 3 EI and 1 upon 3 EI. Now see, I will make this beam like this. This is fixed, this is fixed, this is partially fixed. C, this is B. The distribution factor from B to A is 2 by 3 and B to C is 1 by 3. Now I will write this is A, this is B, this is C. A to B, what is the value of moment? So these all are the incorrect moment. So we will write down or M dash or M bar. So these all are incorrect moment. We need to apply the correction. How we will apply the correction? Using moment distribution method. You will see that the net this MAB is this minus 10, MBA from B to A is plus 10, B to C is minus 16, C to B is plus 16. So now we will say that this joint, the net moment at this joint should be 0, but it is plus 10 into minus 6. It is minus ka 6. This is minus 6. So in order to balance this joint, we will apply plus 6. So minus 6 and plus 6 will be 0. This joint will be balanced. So I will apply a plus means clock. I will apply plus 6 moment at this joint. Now since at this joint there are two members, so this moment will be distributed in two members. Some will be given to BA and some will be given to BC. And in what ratio that will be given? It will be given their stiffness, means their distribution factor. So this some part of this plus 6, this is plus 6, I am applying plus 6. So some part will be given, 2 by 3 will be given to 6, this BA. So 2 by 3 of 6, 2 by 3 of 6 will be 4. So it will be plus 4, and 1 by 3 of plus 6 will be 2. It will be plus 2, right? But this joint is balanced now, because net you can see that 10 plus 4 14, and this is again minus 14, plus 14 minus 14 0. But as soon as we apply some moment at this joint, and if far end is fixed, half of the moment will be transferred to the far end. So half moment, transfer the half moment. This was plus 4, the half of plus 4 is plus 2, and half will be transferred here, this will be plus 1. Now the everything is balanced. Now we can add all the moments of this row, this row, this row, this row. So this will be minus 10 plus 2, it will minus 8. 10 plus 4, this is 14, this is minus 14, and this is 17. So this is the fixed end moment. These are the values of fixed end moment for this diagram. These are the values of fixed end moment for this diagram. Okay, now see how will we calculate these are. Now we have to draw BMD. Dear friends, these are the final end moments which we were needed. This step is called as FEM, fixed end moment. This step is called as balancing, BALANCI, and this step is called as carryover. You can write or no need to write, right? So final end moment MA to B, you will write MA to B is minus 8, MB to A is plus 14, MB to C is minus 14, MC to B is plus 17. Right? Now dear friends, now we have calculated the end moments, means now I can write these are two fixed beam and I can write them as simply supported beam. For example, I write to AB, this was AB and this was 40 load applied, this was 1 meter, this was 1 meter. Now I will write this simply supported beam, and end moment. What is the value of end moment? This is minus means anti-clock, so this is 8. MBA, this is A, this is B. MBA is plus 14 means clock, plus means clock. Similarly I write BC, this is B and this is C, this is value is 12. So MBC is minus 14, minus means anti-clock, and MCB is 17, plus 17. Right? Now I can draw easily the bending moment diagram. Look how. First of all, I will draw simply supported BMD. This is 40 kilonewton at mid span. This value will be PL by 4. 40 into 2 divided by 4 means 20. So this height is 20. This height is 20. This height is 20. Now see, this arrow hits opposite to the reference face, means minus. This is minus and minus is plotted up. So this is minus 8. This is 8 and this arrow also hit bottom. So it is also minus 14 and minus will be plotted up because we want to superimpose. So this is 8, this is 14. Now this value, what will be this value? We can calculate, if this is the midpoint, we can calculate 14 plus 8 divided by 2 means it will be 11. So this height will be 11 and this height is 11. 11 how we can calculate? 8 plus 14 divided by 2 if it is mid. If it is not mid, then we can calculate this is 8. So this is 8 and this from slope as we calculated earlier. So this height, because the resulting BMD is this part is minus, this is minus and this is plus. I want to calculate this ordinate. The total height is 20 minus and this height is 11. So this value will be 9. This value will be 9. Now similarly for this span we can plot, see, WL square by, this will be WL square by 12, WL square by 8. So WL L means 4 square divided by 8. 8 means 24. So this height is 24. This height is 24 plus, right? And these two arrow hit down means negative, and negative will be plotted up. This is 14, this is 17, like this. So this is 14, this is 17, this is minus, and this is plus, this is minus. I want to calculate this ordinate. So how is this ordinate? This ordinate is 14 plus 17 divided by 2. So this ordinate is 14 plus 17 divided by 2. This is 15.5. So this value will be 24 minus 15.5. So it will be 8.5. 8.5. So this is the final BMD. Now we can add them to and write like this. Page. This is the rough page. Now we can like this. See, this is minus 8, this is minus 14, and this is minus 17. This is minus, and this will be, it is also mid. So this value was 8.5. This is minus, and this is 17, this is 8, and this height is plus, and it is 9. This is BMD. Now I can draw the deflected shape. Minus means tension in top face, plus means compression in top face, minus means tension in top face, plus means compression in top face, minus, like this. So this was the beam. Since it is fixed, so it will like this. Like this. This will be like this, right? And more precisely it will be like this, because at this joint it will remain straight like this. So the correct diagram should be like this here. Like this. This is the correct shape. These are point of inflections, right? Okay, now so in this manner we can solve the questions of moment distribution method. So dear friends, let us solve some good quality questions which will be asked in engineering services exam, also in university exam like UPTU or some other universities, but our main focus is on engineering services and administrative service, that is IAS. So let us take some solved examples which I have solved. Okay friends, let us take an example. This is the example. So this is the question. This is a two span beam. One end is this. One end is fixed, other is purely hinge, and other this is partially fixed. What we will do? We will assume that both end edge fixed. This span is fixed and this span is fixed. Now we will calculate end moment. We better know what will be the direction. Direction will be beam will bend like this, so end moment will be like this. Value will be WL square divided by 12. So this value will be 106.67. This will be 106.67. Now this value, if these two I have assumed as fixed, so this will be PL divided by 8 means 30. This will be PL divided by 30. Now dear friends, as I know that this is purely hinge end, so I should make an correction that, however, I have already calculated moment as 30 here, but here should be net bending moment 0. So 30 is clock, so I will apply 30 in anti-clock, so net will be 0 and this end will become hinge end, means net bending moment is 0. But as soon as I will apply 30 in this direction, half in the same direction will be transferred on the far end. If far end is fixed, I have assumed the far end is fixed, so this is the 15. So the total at this end will be 30 plus 15 equal to 45, and here will be 0, but here will be 106.67, or here will be 10. Now I will write the fixed end moment like M bar AB. So because these are not the true moments. Why are not the true moment? Because at joint B the net should be 0, but net is not 0. One is 106 and it is 45. So these are the fictitious moment or false moment. So M bar AB will be, this is anti-clock, means minus 106.67, and M bar BA will be plus, means 106.67 plus. This is anti-clock, means minus, and here will be 0. Now I will distribute the moments. I will first calculate the distribution factor. I can easily calculate the distribution factor as, since far end is fixed, so answer will be 4 EI divided by L. If I take K, this is the K, this is joint B, and this is BA, and this is BC. So BA will be, K will be 4 EI divided by L, 4 into 2 EI divided by L, and this will be, since far end is hinge, so K will be 3 and EI is EI, and divide by L means 4. So answer will be, this is EI and this is 3 by 4 EI. So total K will be 1 plus 3 by 4, 7 by 4. So distribution factor will be, one is 4 by 7 and other will be 3 by 7. Remember friends, the net summation of distribution factor at a joint for all the members should be 1, because we are giving something to all the members, so total is 1 and some part of 1 is to given is this, and some is this and some is this. If there are 2 members at a joint, means a distribution factor, sum of distribution factor of both members should be 1. If there are 3, sum of all 3 should be 1. Right? For example, which we have already calculated in this case. Where is the question? Question is which I have now calculated just now. The question was, wait please. For example, this was the case. Here we would calculated the end moments, the distribution factor 2 by 9, 1 by 9, 4 by 9, 0, 2 by 9. Since this is the single joint, the summation should be 1. This summation will be 1. Right? Okay. Now, so friends, distribution factor are 4 by 7 and 3 by 7. Now, make a table. Since this is A, this is B, this is C. the homogeneous the table should be homologous to this, means this end is fixed, this end is partially fixed, so here distribution factors are used, and this is purely hinged, so no distribution factor is used. So friend, we will make the table like this is 4 by 7, this is 3 by 7, value is 0.517, 0.429. I write the value A, B, C. This is minus 106, this is plus, minus and 0. Now since this joint is unbalanced, so the unbalanced moment is 106.67 minus 45. So unbalanced moment is 106.67 minus 45. Unbalanced moment is 61.67 plus. So we will apply minus 61.67 in order to balance, and the some part of minus 61.67 will be given to this, and some part of minus 61.67 will be given, and the how much part, this is 0.571 and 0.429. So one will be this and one. Now this joint is completely balanced, but since far end is fixed, so half will transferred here, carry over, but no moment will be transferred since far end is hinged. So this is the complete answer. So now add these two, this value, add these to this, add these to this. Since these two are equal and opposite, means our answer is correct. Now we will write MAB is minus, MBA plus, MBC minus, and this 0. Now we will, since it is minus, minus means anti-clock, it is plus, plus means clock, minus means anti-clock, and this is 0. Look, this was first was UDL and other was, this was UDL and this was point load. Since it is at midpoint, see this is the midpoint, so value will be WL square by 8. At this the total ordinate will be WL square by 8 minus this ordinate will be average of these two, so average of these two, so this value is plus value is 62.135, and this value similarly we can calculate, this is PL by 4, and minus average of 71.46 plus 0 divided by 2, right? So in this manner we can draw bending moment diagram, we can draw BMD. Is there any problem? I think there is no problem, because it is so simple. Simply supported BMD will be plotted up, means positive up and negative down, but end moment diagram, if the arrow hit down, down means negative, and negative will be plotted up above of the line, so they will be negative, then only we can subtract two areas. So this is the concept. Take next example. Let us take an overhang continuous beam. This is the continuous beam having overhang. Dear friends, whenever you have the question of overhang beam, we will transfer this load at this support, means this 20 kilonewton will be transferred here, so here will be 20, and a moment of 20 into 2 means 40 will be transferred here. Dear friends, you must have heard that if this is the case, if this is force, this is F force, if we transfer the force in the line of action, means we want to find out force here, so I will say that cut it here, and this is F, apply F, same, means if we transfer load in the line of action, the value remains same. Similarly, if we transfer moment, this is M moment, I want to calculate moment here, cut it and write down the value like this. But dear friends, if we transfer the load perpendicular to the line of action of load, now if I want to, this is the line of action, I want to transfer this load here, I will say that cut it, cut, and write like this. Let us suppose this distance is 2 meter and this distance is 3 meter. We will say transfer this here as it is, 10 as it is, and since it will apply, it will bend the beam like this, this 10 will bend the beam like this, means 10 into 2, a moment of clock, 10 into 2 means 20 moment. So this is the transfer. Same I have done here. What I have done here, A, this 20 will be transferred at C. So at C will be 20, and 20 into 2, 40 moment and 20 load. But dear friends, since we are drawing the BMD, bending moment diagram, if load is just at support, it will not bend the beam. So we will not consider this 20 point load. So we will consider only this bending moment, right? One more thing, dear friends, we discussed only BMD of simply supported beam. If we want to draw BMD of cantilever beam, look, if loading is vertical, so beam bend like this. This is the behavior, means the in top face there is tension, mean bending moment will be negative. How to draw? You can draw, this is P value, this is L length, so value will be P into L. Here bending moment will be P into L. So you can draw here P into L, arrow hit down, here is 0, so minus PL 0 and join it like this. But dear friends, this is the fixed end moment. The fixed end moment we draw like this, means negative we draw up and positive we draw down. So we can draw BMD of simply this cantilever beam like either this or this, both are correct, right? For example, this is the question, this value is W. Now this value will be WL square. Actually there are the certain method to draw BMD which we have studied in the engineering mechanics and strength of material, but here how to learn this diagram directly. Our concern is how to learn the diagram. Some standard diagram should be learned, right? So this will, so it is also hitting down. So BMD, you know that this is minus, and it will be like this, parabolic. It is minus WL square by 2, but we will draw like this, minus, right? So this will be the BMD of overhang portion, right? So let us see this. So dear friends, since this much portion is like a cantilever beam, means this portion is determinate portion, and its BMD I can calculate. This is it is arrow is hitting down, means minus 40, and I can draw its BMD. Minus means up, so minus 40. So this is the BMD of C to D, means this is known. Now I want to draw BMD of A to B and B to C. Dear all, this 40 is applied here. Now what we will see, we do the same procedure. Assume both end as fixed. Assume this is fixed and this is fixed. Now calculate fixed end moment, this and this. But dear friends, we know that this end is purely hinge, so this is 30, this is 30. I will apply opposite 30. This is the opposite 30. Now it will become 0 and this end will become hinge. As soon as I will apply 30, it will apply a 15 will transfer here in the same direction. This is applied 30 and this is transferred 15. So this will be 45 and this end will be hinge. But dear friends, we have to make this beam homologous to this, and at this a 40 kilonewton clockwise couple is applied. So apply 40 kilonewton at this end, so half will be transferred at far end. So this is 40, half of 40 means 20 in this direction, so net here will be 45 in this direction, 20 in this, means 25 in this direction and 40 in this. So this is the similar case as this end is 40 and this is 40. So these are not the correct moment, but we try to make little bit correction at this end. Finally these are not the correct moment. We want to find out correct moment, which will be calculated by distribution, because at this end, from one end this is 106.67 and other end it is 25, so not balance. So first of all we will calculate the distribution factor. How will calculate distribution factor? It will be BA joint is B, so it will be BA and BC. K, C, BA, B to A, it is 4 EI by L, means 4 into 2 EI divided by L means 8. So 4 into EI into 2 divided by L, 8. This will be EI. And since far now beam is not this, beam is this, now I am analyzing this beam and it is seeing that we can see that the far end is purely hinge end. So we can say that the distribution, the stiffness will be 3 EI divided by L. So distribution factor will be like this: EI, 4 EI, add these two and divide EI upon this, and 3 by 4 EI upon summation. Right, now distribution of moment. Look here how we will write. Since it is anti-clock, so minus, m bar AB minus, m bar BA, clock means plus, m bar BC minus 25, and m bar CB plus 40, clock means plus. Look here, write down here. Now you will see that 106.67 minus 25, add these two, 106.67 and minus 25, so value will be 106.67 minus 25, so value is 106.67 minus 25, value is 81.67. so plus 81.67 is unbalanced, plus 81.67 is unbalanced, so we will apply minus 81.67 and its 0.5 will be given this and 0.4 will be given this. So 81.517 into minus 81.67 and 0.429 into minus 31, so these two value. But as soon as apply the moment, half will be transferred to the far end, so far end is so half will be minus 20, but no moment will be transferred here. At this is hinge end, right? So now this is completely balanced. Add these, this is the answer, this answer, this, and here will be 40. So we will write like this: MAB will be minus 129, this is plus, this is minus, this is plus. Now how to draw its BMD? How to draw its BMD? See, this will be the BMD. How? Let us take 129 means 30. However, you have to take the exact value, means 129.98, but we can also, for ease, we can take at 130. So it is, see, minus means anti-clock, minus means anti, and this is plus, plus means clock, minus anti plus clock, and of this portion we already known. This is the BMD of this small portion. And now see, here is a UDL and here is a point load, and these are the supports like this. Right, so now you can say that this will be WL square by 8, means 20 into 8 square divided by 8. This value is total 160. These two arrow hit below.